Types of sets: empty set, singleton set, finite set, infinite set, equal sets, equivalent sets, universal set, subset, proper subset, superset, proper superset, power set. Empty set, a set with no element. This is the symbol of an empty set. Let's name it set E. Another way of writing set E is using the symbol, the null set. The cardinality of set E is equal to 0. This notation simply means the number of elements. Singleton set, a set with one element. Set S is a singleton set. The cardinality of set S is 1. Finite set, a set with limited elements. Example, set F is the set of counting numbers less than 6. The elements of set F are 1, 2, 3, 4, 5. The cardinality of set F is 5. Infinite set, a set with unlimited elements. Example, set N is the set of counting numbers. The elements of set N are 1, 2, 3, and so on. The cardinality of set N is infinite. Equal sets. Two sets are equal if they have the same elements. Example, set E is a set of letters in the word earth. The elements of set E are E, A, R, T, H. Set H is the set of letters in the word heart. The elements of set H are H, E, A, R, T. Set E and set H have the same elements. They are equal sets. Set E equals set H. Equivalent sets. Equivalent sets have different elements but have the same number of elements. Example, given set F and set H. The cardinality of set F is 5 and the cardinality of set H is 5. The two sets have different elements but they have the same number of elements. Set F is equivalent to set H. Universal set. Universal set is the set containing all elements and of which all other sets are subsets. The universal set is represented by a capital letter U. Example, let U be the universal set. Set U is the set of all vowels in the English alphabet. All other sets are subsets of the universal set. Set A is a proper subset of set U. Set B is also a proper subset of set U. All the elements of sets A and B are also found in the universal set. Another example, set U is the set of counting numbers. Sets A, B, and C are proper subsets of set U because a universal set contains all the elements in a particular problem. Subset. Set A is a subset of set B if and only if every element in A is also an element in B. Here's an example. List all the possible subsets of set A. Number 1, a set with 3 elements. 2, 3, 4, sets with 1 element. 5, 6, 7, sets with 2 elements. And number 8 is an empty set. How many subsets does set A have? To find the number of subsets, use this formula, 2 to the power of n, where n is the number of elements. The cardinality of set A is 3, so 2 to the power of 3 is just 2 times 2 times 2 equals 8. Proper subset. Set A is a proper subset of set B if there is at least one element in B not contained in A. In symbol, set A is a proper subset of set B. Example, given sets A, B, C, and D. Set B is a proper subset of set A. Set C is a proper subset of set A. Set D is a proper subset of set A. List all the proper subsets of set A. Sets 1, 2, 3 have 2 elements. Sets 4, 5, 6 have 1 element. And number 7 is an empty set. The set itself is not a proper subset of set A. How many proper subsets does set A have? Since the set itself is not a proper subset, the formula is 2 to the power of n minus 1, where n is the number of elements. The cardinality of set A is 3. Using the formula, 2 to the power of 3 minus 1 equals 8 minus 1 is 7. Superset. Superset is a set containing all of the elements of another set. In symbol, set A is a superset of set B. This is just a reverse of subset. Proper superset. Set A is a proper superset of set B if set A is a superset of set B and set A is not equal to set B. In symbol, set A is a proper superset of set B. Given set A and set B, while set B is a proper subset of set A is a proper superset of set B. Power set. The set of all the subsets of a set. What is the power set of set S? P of S contains all the subsets of set S. How many elements does the power set of set S have? Since a power set contains all the subsets of a given set, it follows the formula 2 to the power of n, where n is the number of elements. So the number of elements of P of S is 2 to the power of 3, which is equal to 8.